Good day, dear students. Today is our lecture number 2, titration methods. So in the first lecture we have talked about the basic rules of the analytical chemistry, their background, history, and so on. So before starting the lecture, please write down this quiz. Previous slide, please. 3 questions, and you have to answer it for me and send it to me via Google Classroom class. Okay, next slide. Titrametric analysis is a method of quantitative analysis which is used to determine unknown concentration of known substance. So here you must know definition of some useful terms like titration or standard solution and titrant and the titration types. So first of all, standard solution is a solution of accurately known concentration. Most of all in analytical chemistry, when we are going to do the experiments, we are working with the standard solutions. It became the different one. So the second one is a titration, the process of determining unknown concentration by adding the small increments of standard solution until the reaction is just complete. So here we can use different types of them. Indicators, and after that titration setup will be the titrant drops. From here you can see the Buret and into the analyte solution in the flask here, and indicator present then changes color permanently at the end point. End point is the point where the drops makes changing the color of the flask's mixture. So overview to the titrametry is a titrametric methods classified into 4 groups. So it's first of all acid-base titrations, where acidic or basic titrant reacts with analyte, that's base or an acid, and the second one is complexometric titrations involving a metal ligand complexation reactions. Third one is redox titrations, where the titrant is an oxidizing or reducing agent, and the last one is precipitation titrations, in which the analyte and titrant react to form a precipitate. So we have the heavy salts. So the titrant I also told about that the reagent added to a solution containing the analyte and whose volume is the signal one. So here the titrant of known concentration or the standard solution, and volume is used to react with the solution of the analyte, so whose concentration is not known. What is the equivalence point? It's the point in a titration where stoichiometrically equivalent amounts of analyte and titrant is react. So endpoint, it's the point where the titration where we stop adding titrants. So when the mixture is changing their color, it will be the endpoint. Indicator is colored compound whose change in color signals, and the endpoint of titration. So also we have the titration error in some cases of experiments. So it's determinate error in a titration due to the difference between the endpoint and the equivalence point. And also we have the primary standard and secondary standard. The primary standard is a standard that is accurate enough, so that is not calibrated by your subordinate to other standards. Also in this standard in chemistry is reliable, readily quantified substance. So also primary standards are stable chemical compounds and that are available in high purity. So this is the used in most very high standardized or standard solutions used in titrations. The secondary reagent is a reagent whose purity must be established relative to a primary standard one, and also we have some different dishes of them when we are using to the titration methods. It's a Buret, it's a vertical cylindrical piece of laboratory glassware with a volumetric graduation. So most of them in analytical chemistry, this is one of the most useful glassware like a Buret. So even the thickness of the lines printed on the Buret matters. So the bottom of meniscus of the liquid should be touching the top of the line so you wish to measure from. So you have to mention it and write down. So equipment also for measuring volume is using analytical chemists variety of glassware, like their beaker, graduated cylinder, for example, volumetric flask, pipette, and dropping pipette. So next. and this is the Buret. So when we are working with it, we can just put it on open and just close. When our titration volumes or endpoint gives us when we're after adding the indicator, it will be changed the color. We are stopping it here, and we're just calculating how much of the drops came in from that. And this one will be our endpoint. Okay, next. Also, we have the common types of the pipettes and syringers. So they are transferring pipette, for example, the AB is measuring pipette, digital one, and this is one from the syringe. It's most useful in the chromatography. Okay, please. So chemical dropper, also this is the types of the pipettes where we working with the chemical dropper is a laboratory tool. Also we have some measured from the volume of the liquid and often as a media dispenser. So next. Also in most of the using in analytical chemistry, we are going to work with laboratory flasks. They have the different volumes, like from the starting from 50 milliliters to 250, and for the large or from the high experiments, we are using 500 milliliters of them. They divide it to the different types of the reaction flasks, multiple neck flasks, Schlenk flask, distillation flask, reagent, and volumetric flasks. Volumetric flasks or the measuring flask or graduated flask is a piece of laboratory glassware. So this one we are using the particular temperature of them. Also the volumetric flask is very useful, and it's used for precise dilutions and preparation of standard solutions, because here we have the some amount of them in the bottom from them, they are closing, and when we are preparing the standard solution, we can keep it for the next lectures. Next, this is the graduated cylinder. It's also very useful and very smart of them. So the graduated cylinder is measuring cylinder or mixing cylinder is a piece of laboratory equipment. So now with this one can measure the volume of a liquid, and also this is also one of the most useful laboratory flasks and beakers in our laboratory. Okay. Also in some cases we can use the funnels laboratory. It can be different one. So laboratory funnels are funnels that have been made for use in the chemical laboratory. So they have different kinds of them, and depending on the specializing applications, they have filtering one, for example, here, also shaped like festal flowers here, or dropping funnels from there, and they have also stopcocks which allow to the fluids to be added to a flask very slowly. Next. Also I said about also the Buret, which is one of the kind laboratory glass for the analytical chemistry. Equivalence point, the point of the titration, which is ending or the one amount of the titrant added in the chemical equivalent to the amount of substance titration. Also the end point, which is the point which is the completion of a reaction, is particularly observed. So we will be just enough to titrating when adding the titrant form, change the color of the indicator. So 3 important precautions are needed when working with pipettes and volumetric flasks. First of all, it's the volume delivered by pipette or contained by a volumetric flask assumes that the glassware is very clean. The second one, when filling a pipette or volumetric flask, sets the liquid's level exactly at the calibration mark, because when we are making some amount of the mistaken errors, we have just the wrong calculation. Also the third one is the liquid stop surface is curved into a meniscus. So from the bottom side we can see which should be exactly even the glassware's calibration mark. So Buret filling instruction, always use a small funnel to fill a Buret, because when we need, for example, 10 milliliters of some amount of titration mixture to fill a Buret, close to the stopcock, for example, because they can add to the flask with the indicator. Then fill the Buret past to the 0 mark, check the tip of the Buret also for an air bubble, because air bubble is also affecting to our error in the calculation. Also takes the funnel out of the burette so that drops of solutions from the funnel will not fall into the burette. So here it's the correct line of the volume adding to our burette. When your burette is filled with no air bubbles, you must level of the liquid exactly to the 0 mark. So here is the level of meniscus, not above, not below, just in a line, correct line of the volume. Next. After filling the burette, a volume of the unknown concentration solution should be taken with the pipette and placed into the conical flask. Here the conical flask also adding a mixture with the indicator, and from here just we have to open and very slowly adding our standard solution. Next. So the solution should be let out of the burette until the indicator changes color and value. For example, it's from the 4 to the 5, it will be the end point. Here you can see from the ice. So this is the meniscus, so the reading is 4.7. Here you can just calculate 1, 2, 3, 4, 5, 6, 7. This one is our end point. So types of the titration, it has neutralization or acid-base titration, precipitation titration, redux and oxidation, or the complex symmetric titration. I have already talked about in the previous slides, but here I also completed with the definitions. So when we are talking about the acid-base titration, as name it says that the base is the acidic one, and when we are going to use it, the method we are calling the titration. So in the first procedure, we are simply going to add an acid solution to the basic solution. This is each solution will be different strengths and or concentration amount, or you will simply observe the relative results. So the properties of the acid solution are standardized and fully known. So by finding this one, the exact amount of acid that neutralized a known solution of base. So it's possible to carry out calculation and find. This titration is very easy one, first of all. Next one. So here you can see that these titrations are based on the neutralization reaction that occurs between acid and base when mixed in solution. Here you can see that acid and bases here making destroying something, and the acid is going from this one, for example the H chlorine, and the sodium hydrogen is going from this one. It's delivering to the water, this giving us the salt, sodium chloride. And acid-base titration is a determination of concentration of an acid or base by exactly neutralizing the acid base with an acid or base of known concentration. So this one is when we are calling an acid-base titration, when the standard solution of an acid is called acidimetric, when the standard solution of an alkali or the base is called alkalimetric. So next, the second types of the precipitation titration. Precipitation titration is most important precipitating reagent is silver nitride. When we are going to work with the standard solution of the silver nitride solution, the most common precipitation titrometric method. Because silver precipitates are usually highly insoluble, and many species from the stoichiometric precipitates with such iodium like chlorine, bromium, ion, thorium, and the CN, also other groups. These precipitates are formed very quickly. So standardized solution or tetrant is using silver nitrate. So next. In the precipitation titration, we are using more method. More titration is used for the determining of halide in a solution. Here you can see the 3 different types of them, and here in the flask we are adding the halide in a solution like a potassium chromate can serve as indicator for the determination of chloride. Here you can see that brick red silver chromate precipitate in the equivalence point of the region. Please next. So more titration has been performed at a neutral or weak basic solution where the pH degree will be equal to the from 7 to 9 or from 6 to 10, because silver hydroxide forms at high pH degree. So while the chromite forms at low pH. Also, if the silver solution is added to chlorine solution containing of small quantity of the chromium oxide, then a silver chloride will firstly precipitate it. So it depends on their pH degree. So next, in the third part of the titration is reduction oxidation. Is based on the oxidation reduction reaction between analyte and the titrant. Here we are using like a standard solution potassium permanganate to determine of the iron with the 2+ ion in an unknown solution. So here you can see that permanganate ion is reduced to a manganese 2 ion in the acidic solution, or only one electron is necessary to reduce the ferrum iron 3 to the iron 2. So therefore 1 mole of the magnesium oxide is like working like oxidizing agent, reacts with the 5 moles of the reducing agent. So here you can see that to form the moles of the ferrum 3 plus ion and 1 mole of the manganese 2 plus, this is in net ionic form like this. So also reactions in which electrons are transferred from one species to another are known as redox reactions or oxidation reduction reactions from the sodium to the chloride ion, like we are having sodium chloride salt. Also redox reduction is made up of 2 reactions, reduction, gain of electrons, or the oxidation, loss of the electrons here. Next. So writing redox equations is in the redox reactions, the number of electrons lost by species being oxidized mass balance is the number of electrons gained by the species being reduced. Also in a balanced redox reaction equations, the number of atoms of each element must be balanced, and the total charge of the ions on the left hand side of the equation will be equal to the total charge on the ions on the right hand side of the equations. So this is the end of our lecture. Please thank you for your attention and wish you good luck on your next quiz.